Okay, question number 3 is about this hyperbola -1 on x and the straight line of x minus 4. Okay, so I've got -1 on x, xy, and I've got, what is it, x minus 4. Okay, so beautiful. I need to find the intersection points. Okay, so intersection points, I'm going to use simultaneous equations because simultaneous equations will give me the x and the y, but I need a y equals and I need a y equals. So I've got 1 on x is one of them and 4 minus x is the other. And I'm going to solve that for x comma y, execute, and you'll see there's my first coordinates, 2 minus root 3, -2 minus root 3, and my second one is 2 plus root 3 and -2 plus root 3, and I've turned them into decimal just to get an idea of roughly where to put the intersection point because I know what the decimal equivalents are. And then I'm drawing a graph of both of them, labelling all of the relevant features. For the hyperbola, the relevant features include equation of asymptotes, the dotted lines of the asymptotes, the other point which I know is 1, 1, labelling it g of x. And for the k of x, I've labelled the equation, I've labelled the x-intercept, and I've labelled the y-intercept. And I've also put the coordinates of the intersection points there. Okay. And they've said, write a definite integral that represents the area trapped between g of x and k of x. We're looking at this area here. And obviously it will be this x value to this x value, top curve minus bottom curve. And you are allowed to put g of x minus k of x as part of the definite integral. And then on a calculator, that's going to look like we are going from, whoops, I'll get rid of that, put that back into standard so I can drag and drop them. 2 minus root 3, 2 plus root 3 of top curve is our hyperbola. Minus, I'm going to open up a bracket because that negative has to attach everything inside the bracket. So I'll put in a bracket and that's to do with dx. And I end up with that's a bit awful, simplify, and that's a much nicer answer, and that's that answer there. Okay, so that's the first part. That's the first part where it's all about numbers. Now when we go over the page, we're now going to consider g of q, where g of qx is negative q on x, where q goes from 0 to infinity but not inclusive of 0. And it's still the same k of x. We're now looking for the intersection point. So if I go up to my simultaneous equations and change that 1 to a q, I can now write that these are my x and y coordinates, and these are the second ones. The values of q that provide one intersection point. Okay, so I'm looking at the structure here and I can see a square root. I will have one intersection point when the square root equals 0. So when q equals 4, 4 minus q will be nothing, so I will have 2, negative 2. That will be nothing. That's also negative 2, so that should be a negative 2 there of transcription error, and that gives me 2, negative 2 as well. And the values that provide 2, well, when q goes from 0 to 4, that will be a positive value. I can't include 0 because q doesn't include 0. and then bigger than 4 will provide no intersection point. And when there are two intersection points, that is when Q is between 0 and 4, there is a trapped region. As shown here, where you do analysis, G-solve integral, and you look at the intersection, and you get this intersection here, I get 2.1314, 2.1314, that's when Q equals 2. Okay, so let's try these to get the rest of them. So I've got, I start with 1, negative 1 divided by x, xe, and x minus 4. xe, open up a graphing window, edit, clear all, okay. Look just down here. Okay, so 1 on x and x minus 4. Maybe if I change my window just to do that. Beautiful. Analysis, G-solve, intersection. I accept the first one, xe, move across to the second one, xe. Analysis, G-solve, integral, intersection. I accept the first one, xe. I move across to the second one, I accept that. That gives me an area of 4.2943. Okay, so now I'm going to change that to 0.5. And that's for x minus 4. Analysis, G-solve, integral, intersection, accept the first one, move across, accept the second one. That's an area of 5.7833. When I do 0.1, same thing. I might clear all that. Oh, maybe I'll press xe and then I drag and drop. Beautiful. Didn't remember the previous ones after you press xe. Analysis, G-solve, integral, intersection. I accept the first one. Move across, I accept the second one. Now notice that this area is filling this triangle, and that the smaller my value of Q goes, closer to 0, the more of this triangle gets filled. And that's 7.39. And the last one they asked me to do was 0.05. And if I press xe, when I drag and drop, it should be the previous graphs. And x minus 4. Analysis, G-solve, integral, intersection. Didn't pick the first one, did it? 0.05. See if I can just grab it to there. Analysis, G, integral, intersection. Got it that time. Enter, across, enter. And that's more of it, 0.76617. Okay, there are those answers. What happens as Q gets smaller and smaller and smaller and smaller? Well, more and more and more of this triangle gets coloured in. So as Q approaches 0, my area is going to approach the triangle 4 by 4, which is 16 divided by 2, 8 square units. If I had G of Q of x and x minus 8, then I would have 8 and 8, 64 divided by 232. And if I had x minus a, then what I'd be having is I would have this line here going from a to negative a. Therefore, that area there will be a squared divided by 2. And that's how you do question number 3.